Okay, we're doing extending laws of exponents today. The notes again are on Blackboard to print these out again. A little bit of this we covered in the bell ringer today. What we're going to do is we're going to do a little bit of application, and we're also going to do combining of the laws of exponents. So let's just jump right in here. All right, so make sure all the numbers in exponential form. If they do not have an exponent, put a 1 as the exponent. Okay, that's important to do when we combine laws of exponents. So if we have this one right here, we have a times b. This is just any number a times b. Then you're going to end up with, raised to the x power. Then you're going to end up with a to the x power times b to the x power. So, like this. And again, only if multiplication. When we start talking about FOILing later, one of my biggest mistakes that I have with juniors is they'll see something like a plus b to the x power, and then they'll try to distribute that exponent. But that only works for multiplication, so please keep that in mind. All right, if you have ax times bx to the y power, then you're going to end up with distributing this over here, distributing this there. You have a to the xy power times b to the xy power. If we have a divided by b, then you're going to end up with a, or raised to the x power. Then you're going to end up with a to the x power, b to the x power, so a to the x power divided by b to the x power. And then if you have a to the x power divided by b to the x power, all raised to y to the x power, or y power, then you're going to just distribute that there and distribute that there. And end up with a x to the xy power divided by b to the xy power. Again, this is important information for you to remember. I'm going to highlight them again so you remember to commit this to memory. And this is one of those, these are those kind of rules or whatever that you kind of have to practice to get better at. Okay, so make sure you're practicing this. And then again, make sure you follow the order of operations, okay, which, you know, parentheses, exponents, multiply, divide, add, and subtract. All right, so let's do some examples with these. I know that sometimes just looking at the variables doesn't help us, so let's go ahead and do some examples. So we have 2 times 3, it's multiplication, so we can do 2 squared times 3 squared. This is going to give you 4 times 9. And then 4 times 9 is 36. Now, it is the same thing as saying 2 times 3 squared, and 2 times 3 is 6 squared, and that equals 36. That is the same. Now, I want to explain something here, because one of the things that I don't want you to get confused with is if I was doing a regular problem, I would probably do this side, this method first. This is showing you a very easy example, but sometimes easier to break it down, and you can do mental math if you do it this way. That's why I'm showing you this method, but you need to understand this rule and how that works. Also, if these are not numbers, like we talked about in the bell ringer today, if these are not numbers, then you would have to, like these over here, then you wouldn't be able to do such an easy problem. Okay, so let's look at B. And again, this is example 1. I want to label our bullet points up here. So if we look at B, that's example 2. We're going to take this power, put it here, and take this power, put it there. So we end up with x 2 to the times 3 times y to the 5 times y to the 3 there. And then we end up with x to the 6th power times y to the 15th power. And we don't ever want to leave that dot. And that's hopefully something you'll take away from this lesson today. Once we're done with all the operations, we need to stick it together. So then we end up with x, 6, y, 15. That dot should only be temporary. Okay, let's keep on moving. Okay, so now we have negative 4x squared times 3y cubed, all cubed again. So what I'm going to do to make this a little bit easier is I'm going to go ahead and work the inside first. So negative 4 times 3. Again, now we're going to multiply. We're going to do the right process with this. So negative 4 times 3 is negative 12. Whenever you're dealing with the big numbers, you do whatever the operation tells you to do. Then I'm going to have x squared, getting rid of that dot, y cubed. All of that cubed. And see, what I did there was, all I did was simplified in here. Okay, I simplified inside the parentheses, and I got negative 12x squared y cubed. And then raised again to the cube because I never did anything with that yet. Now we're going to go ahead and distribute that 3 exponent to everything, including the big number. So now I have negative 12 cubed. Then I have x, 3 times 2 is 6. Y, 3 times 3 is 9. So I have negative 12 cubed, x6, y to the 9th power. In my calculator, if I multiply this out, I end up with negative 1728 x to the 6th, y to the 9th. Notice how I ended up with the negative answer. We've talked a lot lately about exponential form not going to cross the x or y axis, but again, one of the things I talked about on Monday was if you start with a negative, you will finish with a negative. And so here I started with the negative base and I finished with a negative. Now again, that's only if I have an odd exponent. Notice my exponent's odd. So odd exponent, negative number is going to give me a negative answer. If this was an even exponent, it would have been a positive answer. All right, let's look at example 4 here. Okay. Example 4, we're going to take this. We got negative 3/4 squared. We're going to take this to here and this to here. So then we're going to end up with negative 3 squared over 4 squared. So then we're going to end up with 9, because negative 3 squared is 9, over 4 squared is 16. So I have 9/16. Any questions there? Make sure you write them down and bring them to class. Okay? And then example 5 is going to go with this one. Move it up a little bit more. Okay, on example 5, we have a to the 4th power divided by a squared, b to the negative 2 power, all raised to the 2nd power. So if we follow our order of operations, again, if you look at the top of your paper in that bubble, it says parentheses, exponents, multiply, divide, and add and subtract. So the first thing we're going to do is we're going to go ahead and work this out. Okay, we're going to work out the parentheses. So the first thing I'm going to do is I'm going to look at my a values. See, these are like basis, right? And this is where it starts to get complicated because I have a and b here, but I can look at the a values only. So my a value is a to the 4th divided by a squared. I'm not going to rewrite this as a to the 4th over a squared times 1 over b to the negative 2nd power. And then all of that, of course, raised to the 2nd power. I could rewrite that. Sometimes that makes it a little easier for some people to rewrite that. That way I'm pairing up, I'm matching up my a values and I'm matching up my b values. And if there's no other b value on top, I just stick a 1 up there. So if I work this out, because of our division law of exponents, I'm going to subtract, right? So I'm going to have 4 minus 2. Now here's something I want to try to teach you. If you are subtracting and you end up with a positive number, put your result on top, positive. If you end up with a negative number, put your result on bottom, negative. On bottom, positive. For example, here I have a to the 4th over a squared. Well, then I'm going to take my exponents. I'm going to do 4 minus 2 because of the division law of exponents, and I'm going to get a squared over 1 times 1 over b to the negative 2. Okay, all that's still squared. Now, I need to go ahead and work out this part, the b part now. When I work out this b part, notice how I have a negative 2. Remember what I talked about in class about that elevator button. Okay, let's get it to, I hit that elevator button and what happens? Well, my a squared over 1 times, if I hit the elevator button, that means I'm going to move it up to the top and to make it positive. So then I'm going to end up with times b squared over 1. And of course, all of this squared. Okay, let's simplify. So now I have multiply straight across because I'm dealing with fractions. So a squared times b squared is a squared b squared. 1 times 1 is 1 over 1 all squared. Okay, well a squared times b squared over 1 is just a squared b squared squared. And I'm doing a lot of steps here just to show you the process that we do to go through this. So please understand that I'm not trying to, normally we wouldn't write all these steps, but I'm just kind of showing you all the process. So now 2 over here and 2 here, all that multiplication because it's a power to a power. So now I have a to the 4th power, b to the 4th power. And that's our answer. We cannot simplify anymore. I would recommend going back and rewatching this and working step by step. I'm going to do another example over here that's a little more complicated, but I would watch this again step by step. So rewind it and watch it again so you understand that fully, because this is just getting more complicated. We're going to continue to add more and more variables to this, so you have to be careful and go piece by piece. This is really simple, but you just got to be careful and go piece by piece. All right, so let's look at f. I have 2x squared divided by 3x cubed y squared, all raised to the 3rd power. Again, I'm going to start with the inside. Now I'm going to skip some of the steps I would normally skip. Okay, can I divide 2 and 3? Not evenly, so I'm just going to keep it 2 over 3. I'm going to draw a long line because I don't know where I'm going to go. Now, this is what I was talking about a second ago. My exponent rule tells me to, the division law of exponent tells me to subtract these exponents. I would subtract 2 minus 3. Well, when I do 2 minus 3, I'm going to end up with negative 1. Well, rather than having negative 1 for my exponent, what I'm going to do is I'm going to put it on the bottom. And I'm going to have x to the 1st power, which is just x. So I'm just going to put x to the 1st power so we don't confuse anybody. Okay, so normally what I'd have here is I would have 2x to the negative 1st power, and I would have it up here. But then what I need to do is, once I push the elevator button, I end up on the bottom. So what I do instead is I say 2 minus 3 if the answer is negative. So I have negative 1. I put it on the bottom, and I leave it positive. And then, of course, I have y squared. Okay, all raised to the 3rd power. Now I'm going to go ahead and distribute that 3rd power out here. Make sure you get it to everything. Okay, and then here's what I'm going to end up with. 2 to the 3rd power is 8. If you don't know how to do that, put it in your calculator. There's nothing else on top. 3 to the 3rd power is 27. X to the 1st power raised to the 3rd power. Okay, 1 times 3 is 3, so I have x to the 3rd power. And then y squared raised to the 3rd power, or 2 times 3 is 6. So then my answer is 8 over 27 x cubed y 6. Okay, I know some of you are probably sitting there right now going, wow, this is a lot to take in. And it's really not. The best way to be successful at exponents is just to take your time and work slowly through this. All right, let's look at this number 2. It says examine the problem C and problem D. What occurs with negative coefficients when powers are distributed into the problem? Okay, well, even exponents will cancel out the negative exponents. So like here in D, if I take an even exponent here, it no longer becomes negative when I square it. It becomes positive. But when I go down here on C, I take an odd exponent to a negative number, and it keeps that negative. Sorry, that was on example C. Let me come down again. So here, even exponent, negative number, the result is a positive 9. Here, odd exponent, negative number, the result is negative 1728. So odd exponents keep negative numbers. Okay? So that's what I'm going to write. Odd exponents keep negative numbers. Even exponents cancel out the negative value. And that makes sense because if I do a negative times a negative, it becomes positive. Wow, I'll write really crooked. All right. Our last page. Okay, let's quickly go through these problems. These are more application problems. Okay. All right, it says the size of a genetically mutated bacterium is given by the expression 2p to the negative third power, where p represents the length of the original bacterium in picas. Write the expression in simplified form without a negative exponent. Okay, so all I want to do is take this 2p, that's a big word problem that has a lot of information, and all I want to do is take care of that negative exponent because we don't ever want a negative exponent. Okay, now, does this negative 3 have anything to do with this 2 right now? Okay, the answer is no, because it is not attached to that. It's not outside parentheses, so it's only attached to the base of p. So we don't do anything with 2. So when we do this, 2 is going to stay 2. Now, when I hit the elevator button, where is it going to go? Well, it needs to go to the bottom floor and become positive. That's all it's asking you to do. The 2 stays on top because it's like saying 2 over 1, which is still 2, and the p goes on bottom. If you wanted to break this down, basically what I would have is 2 over 1 times p to the negative 3 over 1, and then I'd end up with 2 over 1 times, once I hit the elevator button, 1 over p cubed. If I multiply straight across, I have 2 times 1 equals 2 over 1 times p cubed is p cubed. Same answer. Okay, this is just a long way to do it. I just wanted to show you the proof there. Okay, let's look at number 4. It says, what value of A will make the statement below true? So I want to solve for A. Okay. Well, the first thing I want to do is start to work this inside out as much as possible. So here I have 12 divided by 4 is 3. Okay. Then I have x. Then I have x. A divided by x to the 5th power is the same thing as saying x a minus 5. Okay. And then all of this is to the 3rd power, which equals 27 x to the 12th power. Okay, so if I keep working this out, I'm going to distribute this and distribute this, and 3 to the 3rd power is 27. Okay, and then I have x to the, and then we did this something like this in the bell ringer today, 3a minus 5 equals 27x to the 12th power. So now I just need this side to match this. So all I really have to do now is take this down and do 3 times a minus 5 equals 12, and to solve that. Okay, so if I distribute, I'm going to have 3a minus 15 equals 12. Add 15 to both sides to solve. I'm going to end up with 3a equals 27. Divide both sides by 3. A equals 9. Okay, here's the thing I'm going to tell you right now, because I know that this is what some of you are going to do. This is too hard. This is too much. I can't do this. But if you skip this, I promise you, you will fail this quiz on Friday. If you skip this, I promise you, you will fail this portion of your STAR exam. These are really not that difficult. It's a lot of steps, and it can be complicated. That's why it's so important to memorize your exponent laws. You can do this. So just take your time and do the best you can. Okay? And do not skip these problems on your homework. Do not skip these problems on test, or you will fail. I promise. Please do the best you can. All right, let's look at the next one. It says the figure below shows a rectangle. Write an expression for the area of the rectangle. Okay, we did something similar to this on a smaller scale for our bell ringer today. So again, start with this. Area equals length times width.
Teachers, pardon this brief announcement. All JV1 soccer girls come to Don Floyd for practice for today. Also, if you are an FCCLA and are scheduled for trash pickup today, it has been postponed until next Tuesday from 4 to 6 after school. Thank you all.
Okay, so when I put length times width in there, my length can be this. It doesn't matter which one because you're multiplying. So 3x to the 4th power y, all that squared, and then 2x cubed y squared. Just continue to work this out. Let's go ahead and take care of this. So then I have 2 goes here, 2 goes here, 2 goes here. So then I have 3 squared is 9. X to the 4th squared is 4 times 2 is 8. So x to the 8th. Y squared, y to the 2nd power is just y squared. So 1 times 2 is 2. Times 2x cubed y squared. Now I can multiply these together. Okay? I would just do the number, match the coefficients. 9 times 2 is 18. Okay? This is basically going to do this. 9 times 2. And then you have a separate problem, which is x to the 8 times x cubed. Okay, x to the 8 times x cubed. Multiplication law of exponents. 8 plus 3 is x to the 11th. And then over here I have times y squared times y squared. Again, I'm adding my exponents. So 2 plus 2 because I'm multiplying. And then I get y to the 4th power. So the area of this shape is 18 x to the 11th power y to the 4th power. Okay, is it practical in everyday life? Not necessarily this, but using exponents will be practical. We've talked about jobs that had that. We talked about situations that have that. So this is something important to learn. All right, these are, again, these aren't even the most advanced problems. These are just more difficult problems. You need to be able to do this on your own. You need to keep practicing. I encourage you to watch the video again, go back, rewind, make sure you understand each step. If you have any questions, come see me in tutoring. Have a good evening.